So this video is a precursor to the neural network implementation and math videos. Neural network are a part of a large universe of AI and machine learning, the specific terms that you'll continuously hear about if you're pursuing this field. So I thought it's best to cover some of these terminologies. Now, if you've come across AI or if you've been learning about AI, you may have seen this Venn diagram. We have AI, you have a subset of AI called machine learning. I'm just going to write ML, and you have a subset of machine learning called deep learning. Let's look at these terms. AI is about mimicking human intelligence, so much so that it's almost indistinguishable if a certain task is done by a human or a machine. Let's think about driving. If you drive, you know that a driver must be reactive to a lot of different situations. Driving on a sunny day is different from driving in snow. Driving in slow traffic is different from driving on a highway. A self-driving car is an AI that manages to do just that. So AI can have a lot of machine learning components combined with some mechanical components, perhaps even some rule-based components to be able to do a task well. ML or machine learning is about learning through data. So we learn through data. A popular example that you may have come across is spam filters. Given enough learning has been done on how spam mails look, ML algorithm can actually identify and mark spam emails. Machine learning is where neural networks actually sit. But you'll find that most applications of neural networks happen in this space called deep learning. And deep learning is nothing but large ML models. Right? So it's just a lot of ML layers stacked together. We'll be looking at deep learning models in our other videos. Now let's dive into machine learning. Machine learning has a lot of different types of learning algorithms. We'll be considering three of them today. We have supervised learning, we have unsupervised learning, and we have something called reinforcement learning. Right? And supervised learning deals with certain types of problems. We'll be looking into two of them, namely regression problems and classification problems. So now let's look at supervised learning. Supervised learning is when we have a label set of data given to us. What does that mean? Let's take an example to understand. Say I have a table in which I have the age, the weight, some measure of calcium count, and percentage chance of back pain. Looking at this data or looking at these labels, it might be intuitive that age, weight, calcium count somehow correlate and help us find out what the chances of us getting some back pain, right? And say I have tens and thousands of rows of this data. We know that there is some relationship between this, which is our input, and this, which is our output. What we don't know, however, is what that relationship is. So this is the kind of supervised learning problem where we're going to feed this known data into our learning algorithm, and it's going to help us find a relationship. And most neural networks actually solve for supervised learning problems. Inside supervised learning, we have two types of problems that are commonly dealt with. One of them is regression. Now, regression problems are problems where the output is continuous. What does that mean? Well, the example we just took here is actually a regression problem. Because the output over here, which is the percentage chance, can take any value between 0 to 100%, or 0 to 1 if we scale it down. Right, so this is a regression problem, and you might wonder, how do I visualize this problem? So it's very similar to our intuition video that we previously covered, but I'll show it here again. So I have percentage chance on my y-axis, and say I just take one feature, say calcium count, and I'm just going to write cal count here in our x. I have a bunch of data in this Cartesian plane. The idea is, again, the learning algorithm needs to find a line or certain curve that fits this data, and given some unknown calcium count, we'll find the corresponding percentage chance on that line of equation. So that's how you visualize a regression problem. And once again, the output is continuous. It could be any value in this percentage chance y-axis. In this y-axis. Now, let's go to the second type of problem that is commonly dealt with, which is classification. Now, unlike regression, the output in a classification problem takes discrete values. What does that mean? Well, let's take an example to further elucidate. Say we have height, so that's height and weight. And we have is obese. Once again, this is a supervised learning problem, so the labels are available to us, and we have tens and thousands of rows with this label data set. But here, the output is discrete values, yes and no. No matter what the height and weight is, no matter what values the input takes, the output is not any continuous value, unlike like we saw in regression. It's just yes or no. This is a classification problem. So you might wonder, how do I visualize this? So let's further look into it. Let's say I have height in my y-axis, my weight in my x-axis, and I'm drawing some points here. So X denotes those who are obese, so yes for the obesity, and O denotes those who are not obese, so no. And what we really want the learning algorithm to do is to find a line, and again, it could be a curve or some sort of plane, depending on dimensions, depending on complexity of the data, What it should do is it should clearly demarcate the two discrete values or the n discrete values. So this is for the non-obese and this is for obese. And you'll see that I've tried to draw this out with real world relationships where someone with a more height but less weight is non-obese and someone with less height but a lot more weight is tending towards obesity. That is for classification. Now let's move on to the next type of learning, which is unsupervised learning. So let me just write that down. It's unsupervised learning. And as the name suggests, it's sort of the opposite of supervised learning. And in unsupervised learning, you don't have a labeled data set. You just have rows of data and you don't really know what the relationship is between them or if there is a relationship between them. Let's take an example to understand. Say you have a content website. So this is your content website. And in this content website, you take in submissions like authors posting certain articles. And on a certain day, you get, say, 10,000 articles. And now you have a task. And the task is, can you filter out all articles based on AI/ML? It's definitely difficult to go through 10,000 articles one by one. So what do? Here's where unsupervised learning comes in handy. Unsupervised learning finds similarities between these 10,000 articles. It runs some algorithm to find similarities, and then it clusters them. So there are a lot of clustering algorithms when it comes into unsupervised learning. We won't be looking at it into detail right now, but they exist to find similarities and find the relationships that we can't see. Finally, we have reinforcement learning. So reinforcement learning is very similar to how you would perhaps train a pet. When your pet does something you want them to modulate, some behavior you want them to modulate, you reward them, hoping that they'll continue modulating that behavior. So in reinforcement learning, we have something called reward maximization, wherein a machine, when it steps in the right direction, is rewarded, and the whole objective is for the machine to try to maximize that reward. And through this, work on improving. So that's the sort of learning and what AI is, ML is, and how they all fit in. That's a lot of information and it shows you how vast this world of AI is. My idea is to cover as many topics as I can and make it fun and easy for you to understand. At the same time, I don't just want to dwell in the technical aspects. I'd also cover products that use cutting edge AI and solve for some really cool use cases. So if you're interested in all this content, please like and subscribe to Beyond Instructions.